This is our Notifier 50X system. Today we're going to use it to demonstrate some issues that can happen with your signaling line circuit, otherwise known as an SLC. So let's get to it. When wiring a system utilizing system sensor devices, if one of them gets wired up backwards, and that means flipping the plus and the minus or the positive and the negative, that can cause a short on the system, on the signaling line circuit. The way to check that, go to the panel, make sure you have your meter. If we measure our voltage on the signaling line circuit, we know it should be about 16 volts. We're reading 0.08 volts on that. So something's wrong here. We got a short. And what will happen is on this particular panel, about every 30 seconds it's going to beep again, because a short on the SLC is a pretty serious matter. None of the devices are working right now that are on that circuit. So what I would do is pull this connector off. If you have a spare connector, an empty one, you can plug it in. Okay, there's no voltage yet. The system hasn't tried to reapply power to it. What we can do now is ohm out that circuit. And I'm reading some resistance, switching the leads. I'm getting different measurements each way, but I'm not getting a short. It's not shorted. A better way to tell what's going on here is to use the diode check in this case. And you'll notice if you switch your leads around, you're obtaining a reading either way. So what we need to do now, we can make an assumption either something's wet, or more likely there's a device wired backwards. But the symptoms are very similar to both of those problems. So what we'll do is we'll take a look at how to isolate this issue. The short is gone off the system now, and it's just showing that everything is not communicating because we're still unplugged. What I'm going to do is go back to voltage, just check our output, make sure we have voltage there now, which we do. So now you can plug your connector back in, and then you're going to have to go out in the building and locate where that backwards device is. The panel beeped because now in the list the short has returned right there. To locate which device is wired up backwards, you're going to have to walk away from the fire panel, go out into the building where that signaling line circuit covers. You should be able to tell if you're in the right spot or area, because none of your devices are going to be blinking. None of them are communicating with the panel right now because one of them is wired backwards. So what you do after you've examined the area of the building, determine, take a best guess, where is halfway, take a device down and open up the circuit. So for this purpose, really only need to isolate one side of the circuit, and with the meter on volts we can check them both. So there's one wire that's got voltage on it, that one does not. So this one here is good, back to the panel. Now remember, you may have to wait a few seconds for the voltage to come back online. So this is the circuit that goes away from the panel. If I happen to look down the hallway, I notice this detector's trying to reestablish communication. So from this point back to the panel, we should be okay now. So I'm going to go back, use the diode check setting on the other wire, take a measurement, and I'm getting continuity in both directions. So I know that my backwards device is further away from the panel than this point right here. So the thing to do now, you can put this back together and move to another location. Notice that this device here is no longer blinking because I've reconnected the bad part of the circuit, so it's not going to be able to communicate. So if we come down to here, let's just choose that's the next location. What I notice here, this is marked as the negative, that is marked as the plus. Someone replaced the device or installed the device and wired it backwards. This should be a relatively easy fix. I've seen this happen, perhaps in a building, did a little renovation, replace some ceiling tiles, and they may accidentally wire up a detector backwards when they put it up. So simply switch the wires around, put plus on plus. We can confirm our plus and minus to make sure we're right here, that they didn't mess it up in a junction box. Yep, red is plus, that's how it should be. So we'll get this reconnected and see how it works. Okay, so you've got the wires switched around so that the reds are on plus and the blacks are on the negative. It's molded right into the base there. We'll do one last check before putting the detector in and going back to the panel. Okay, we've got our voltage, it's the correct polarity, red to red, and it's not showing negative voltage. See, if I switch the leads around, it shows negative voltage right there. Put your detector back in, and we can see it's trying to establish communications. Now when you go back to the control panel, you can do one last check at the terminals. Make sure you still have your voltage. 16 to 17 volts is good. I had left this in programming mode so that it wouldn't constantly be beeping while we were taking things apart. So now we went back to system normal. What you can do, I just want to show you something here so that it doesn't show all the troubles on the devices when we unplug this. I'm just going to go into programming mode, leave it on the enter password is fine. If we unplug this, remember we were getting a diode reading both directions when the device is wired up backwards. Now when you measure it, it has to be unplugged because you can't have power on the circuit when you do this. I have no continuity when red lead touches red wire. Flip them around and I have continuity in that direction. So you should only have continuity in one direction if all the devices are wired correctly and none of them are backwards. When you're done with that, you can just escape out of that programming menu. When it's done initializing, it should just go back to normal condition and you're all set. You fixed the problem. Just to demonstrate again what a proper SLC meter reading should be when the system's in normal, I'm going to just show this again on another Honeywell panel, the S3, that also utilizes the system sensor devices. Before we do that, I'm going to bypass our SLCs so that when I unplug this, it doesn't give us a list of all the devices not communicating anymore. So we'll get our meter, make sure you set it to the diode check, unplug your SLC, hopefully you can see plus and minus. With the red lead to the positive side of the SLC, the red wire, you see you do not get continuity. If you put the red to the black and the black to the red, then you have some continuity. That is how the SLC should read if everything's wired up properly. Another issue that can cause faults on a signaling line circuit is water intrusion. Maybe there's a roof leak, or perhaps a water pipe is leaking. In this example, we have a control module. Maybe it's in a mechanical room to shut down air handlers or do some sort of control like that. Let's see what happens if the signaling line circuit gets moisture across it. Here we've got a SLC short showing on the panel. If we clear that fault by drying it out, it should restore to normal. Once the system realizes there's no more excessive current flow, the signaling line circuit will start working again and the devices will start communicating. Here I've simulated the water infiltration again so we can get a closer look at how the fire alarm panel might react to it. What can happen with water infiltration? It can affect the communications of the control panel with the individual devices. What occurred this time was the devices started going offline, losing communication and not answering back correctly. So all of them went into trouble, and then eventually the system did indicate a short on the SLC. So we'll take some meter readings and see how that looks. On this particular panel, the signaling line circuit hooks up right here. So what we're going to do, let's start with measuring voltage. Make sure your meter's on DC voltage. And if we measure our voltage across the terminals, 0.05. So what's happening there is that moisture intrusion is causing too much current flow and it's shutting it down. Now if we put a blank terminal board in its place, we'll see that the voltage restores. Now that can take a few seconds, maybe 30 seconds or so, because the panel shuts off the output and then it reapplies power periodically to see if that short is gone. So now if we take our circuit that has the water intrusion that the panel is interpreting as a short, switch our meter to resistance, we're reading about 4 kiloohms of resistance. So it's not a dead short. It's not as if the wire shorted out. It's just that there's allowing some current flow. If you switch your meter to diode check, that increases the voltage output on the terminals a little bit. So we definitely have current flow through this. So after you find the water leak, or the wet device, so to speak, once you remove that condition and then recheck your circuit, notice the resistance difference. It's now up to 15K because it's reading through some of the devices, and we'll get different readings if you switch your meter leads. Notice if I put the red on the positive side, now I'm in the mega ohms. So we should be okay now to reconnect our signaling line circuit. And now the system's initializing, so it seems to recognize that there are some points communicating on the loop, and our voltage is back up where it should be, which is about 16 to 17 volts. It fluctuates because it is a communication circuit. So that's what can happen with water infiltration on a system. Another error that can occur on a signaling line circuit is duplicate addresses. So let's take that pull station at the back exit that was supposed to be dialed to 05 and dial it to 50, which is the same as the control module, and let's see what happens. This is telling us now that that pull station is no longer communicating. That's what invalid reply means. Acknowledge that. And we have a trouble saying that there's a double address on 50. So if you were to troubleshoot this, this usually happens during initial installation or during maintenance if a device is replaced, and you come back to the panel and see these faults. You don't need to go check the control module. What you need to do is go to that pull station location and check its settings. Notice that the LEDs on both of those devices are no longer blinking. So if we fix the address, redial this from 50 to 05 like it should be, then the devices should start communicating with the panel again and the system return to normal. Another type of fault that can occur that usually happens while the system is being installed is if the installer forgets to set the switches. Every device has an address switch inside of it that you dial to the number that is engineered to be at that location. So you could program this as a back exit pull station, and the drawing should say dial this one to 05. But what happens if we dial it, left it at 00 as it comes out of the box? And we'll do the same thing with the control module below it. Notice the red light lights up and the panel's telling us that there's a problem now. Doing the same thing to the module below, we'll dial that to 00 and we'll see what the panel says about that. There it is. The panel is telling us that it lost communication with address 50. Notice though on the control modules the light doesn't come on steady, it continues to blink. So now if we look at the control panel, we see we have a trouble here on that pull station at the back exit. It says invrep. What that really means is invalid reply. It's not talking back to the panel, and this address is on the first loop monitor 005. Additionally, that control module is not communicating with the panel anymore, and this address is supposed to be 050. So what happened? The installer, he put up the devices, wired them up possibly, and forgot to dial them. So you'll have to go check those. Go to the devices, make sure that they're actually wired and connected into the system, and simply dial them to the correct address that they should be. And the system should go back to normal. It's initializing because it found those other devices, and once it's done, it'll go back to normal condition. The same sort of thing can occur with a sensor. So if we remove a sensor, set the dials to 0, and reinstall it, after correcting the dial settings, the panel will initialize because now it's found the device again, and once it's done, the panel will return to normal. The panel's interrogating this detector right now because it's still initializing, and now it's done, and the system has returned to normal. Note one thing: when we were looking at the display, it showed the devices that were no longer replying, but it did not indicate that there was anything dialed to 00, which is not a valid address. Some panels will tell you that there's something dialed to 00. So it depends on the manufacturer and the model number of the panel, exactly how it's going to display the faults. We hope that you found this video to be helpful and informative. Please like and subscribe for more content.